This is an AI-generated instructional short of improving app health with health modeling and chaos engineering. In this session, I guide you through what app health truly means, why it matters, and how to enhance it using resilience principles and practical tools. Together, we'll explore key concepts, demonstrations, and strategies to make your applications more reliable and resilient for the long term. We focus on app health because every business depends on applications to power core operations. Downtime and latency aren't just technical hiccups, they directly threaten business continuity. At Microsoft, we approach app health as a shared responsibility spanning platform resiliency, architectural best practices, and resilient code. Starting with the robust Azure platform, you design highly available architectures with disaster recovery, and then build resilient code fortified for reliability engineering. When combined, these layers protect your app from downtime and latency, ensuring seamless operation. We don't just help you start resilient, we support your application's resilience continuously throughout its lifecycle. This involves understanding your workload's criticality, designing for resiliency, automating risk reduction, and leveraging zonal support to increase availability. The process is ongoing, regularly assessing, prioritizing fixes, and updating your app's posture to stay secure and reliable over time. With continuous evaluation and compliance policies, your application remains healthy and resistant to failure long term. App health spans four main pillars. First is zone redundancy, with geo-redundancy for critical needs. Second is code-level resilience, applying patterns to prevent failures. Third, health modeling and chaos engineering fall under reliability engineering, which today's focus will cover. This includes optimizing observability, visualizing app health, and testing remediations to confirm your app's true resilience. Before demonstrating, I'll introduce a useful reliability engineering framework guiding these efforts. The Azure reliability engineering process consists of 5 key steps to holistically build resilience. Step 1 is defining critical flows, the distinct functionalities your app performs, which may have dependencies or independent components. Step 2 involves creating a health model that visualizes these flows and component relationships to quickly identify issues. Then, conduct failure mode analysis to enumerate possible faults like downtime or latency and prioritize risks impacting your business. Fourth, implement mitigations focused on reducing high-risk vulnerabilities. Finally, validate these fixes by running chaos experiments to test real-world resilience. Later, a demo will show this process in action with Chaos Studio. Health modeling's ultimate goal is answering, is my app healthy? Traditional monitoring, dashboards, alerts, and status lights provide signals but often leads to alert fatigue. Health modeling aggregates these signals into a single health state that factors in business context, such as how component failures impact vital user flows. For example, if a key event hub falters, the model reflects its effect on purchase processes, surfacing only meaningful alerts when necessary. This lowers noise and simplifies monitoring by prioritizing real issues. Here we see a system architecture with components of a web app tied to user flows, adding comments, catalog listings, and static content. An issue in Azure Event Hubs cascades upstream, breaking the background processor and preventing users from adding comments. This health model maps low-level problems to user-facing effects, helping troubleshooters quickly identify root causes like a specific event hub under pressure. Such contextual insight accelerates finding and fixing issues, improving operational efficiency. Building a health model starts with mapping your app's structure components, dependencies, and normal signal baselines. Simple tools like paper or diagramming software work for this. Once mapped, you deploy the model in a cloud monitoring service that continuously checks component health metrics, flags when thresholds are breached, and propagates health state changes through the app's graph. This propagation adjusts related components' statuses to reflect overall impact, a crucial but complex mechanism. The system then triggers alerts based on these health states rather than raw metrics, reducing alert fatigue. Visual dashboards make it easy to see your app's health at a glance. Azure Monitor Health Models will soon offer an integrated cloud-native solution to build and manage these models efficiently. The Health Model Designer offers a visual interface to construct your health model by connecting nodes that represent resources and their relationships. You can manually adjust the model or automate deployment via infrastructure as code for consistent configuration. Automatic discovery updates the model dynamically as your environment changes, reducing manual upkeep. This streamlined approach simplifies building complex models at scale. The upcoming demo will showcase how to interact with this designer in real time. Each health model entity can include multiple signals, metrics, and logs combined to monitor different aspects continuously. These signals have thresholds for degraded and unhealthy states, configurable as fixed or dynamically adjusting values based on trends. The Edit Signal Definition interface allows fine-tuning parameters like metric type, refresh rate, aggregation, and thresholds with live previews. Automated health state management updates component health based on signal changes and supports propagation of these states across dependencies, giving you insight into downstream effects. The demo will illustrate configuring and customizing these signals effectively. In private preview, customers have developed sophisticated multi-layered health models nesting components hierarchically. Propagation of health states from child to parent entities highlights issues precisely, instantly turning red when components fail, which simplifies problem detection. Alerts trigger based on these aggregated health states rather than noisy, individual signal thresholds, making notifications more actionable and relevant. This feature demonstrates the power of holistic health modeling, crucial for operational agility. Visualization is key to reducing alert fatigue. We provide two views, a point-in-time overview showing your app's current health and a historical timeline for trend analysis. Integration with Azure dashboards and workbooks lets you monitor health natively within your management tools. Visualizing health data outside Azure will soon be possible through modular packages, enabling deeper customization and embedding. This makes understanding your app's health clear, intuitive, and quickly actionable. To verify that your failure mode analysis and mitigations work, you apply chaos engineering, intentionally injecting faults to validate your app's resilience before real incidents occur. The Azure reliability engineering process begins by defining critical flows, building a health model, and analyzing failure modes to prioritize risks. Mitigations are implemented accordingly, then chaos experiments validate their effectiveness under real-world stress using tools like Chaos Studio. This approach moves resilience from theory to practice and protects your app proactively. Azure Chaos Studio is a fully managed service designed to validate resilience by running fault injection experiments on your applications. Integrated tightly with Azure tools like the Portal and Monitor, it supports manual and automated testing via REST APIs and SDKs. Its extensive fault library includes agent-based faults and service direct disruptions. Advanced orchestration enables precise fault sequencing and workflows that simulate realistic failure scenarios. Safety features like role-based access control and impact radius limits ensure experiments cause no unintended harm. Reliability is a shared responsibility across the Azure stack. At the top layer, you test your application using agent-based faults simulating resource pressure and dependency faults on VMs or containers. Below that, service direct faults let you inject disruptions directly at the Azure service level, testing failovers, latency spikes, and outages. Finally, Microsoft maintains platform resilience by internally running infrastructure chaos tests invisible to customers. This layering ensures every stack level is validated, giving you confidence in end-to-end reliability. A Chaos Studio experiment targets your app and its dependent resources, injecting faults into compute, storage, or network components. Valid experiments require active traffic, achieved through integration with Azure load testing, which generates synthetic customer load during injects. Observability is critical. You establish baseline health before injecting faults, monitor impacts live, and confirm full recovery afterwards. The orchestration layer precisely controls fault timing and sequencing for safe, effective resilience validation. The session demo shows this orchestration and its value in real-world validation. Currently, Chaos Studio enables ad hoc experiments secured by robust role-based permissions, supporting diverse faults from agent-based to service direct. Experiment templates simulate common failures like Azure downtime or identity provider outages. The fault library exceeds 40 types and continues expanding, including integration with open-source tools like Chaos Mesh for AKS clusters. Chaos Studio is broadly available globally with ongoing customer-driven enhancements. Customer feedback emphasizes designing chaos experiments around scenarios rather than individual faults. Chaos Studio's broad library lets you inject resource pressure, process kills, network issues, and targeted service faults to simulate disruptions. Predefined scenarios cover availability zone outages, DNS failures, region resilience, and emergency certificate rotation. Best practice is to define the scenario first, then select corresponding agent and service direct faults to build coherent, focused experiments that simulate realistic failures, ensuring relevant and effective resilience testing. Two key scenarios demonstrate Chaos Studio's power, simulating availability zone failures on VMs and scale sets, and using Chaos Mesh to inject faults in AKS clusters. Fault templates enable quick setup of zone failure simulations by disabling scale sets or failing VMs. Chaos Mesh injects pod failures, resource pressure, and network faults inside Kubernetes clusters, also supporting managed authentication for security. The Azure portal integrates experiment design and monitoring, with safeguards and JSON parameterization for fine control. This workflow lets you conduct chaos experiments confidently and safely. Chaos Studio is evolving to simplify chaos experiments with a vision of one-click runs. The roadmap includes now available features like private network experiments, dynamic target selection, managed identities, multi-fault templates, and AKS integration. Upcoming additions bring application-centric automated experiments, continuous validation, and regional expansions. The future promises replaying outages, randomized chaos, game day management, enhanced CI/CD support, and extended fault coverage beyond compute resources. Your feedback shapes this roadmap, ensuring Chaos Studio meets real-world resilience needs. You can start improving your app health today with a simple 3-step process. Assess your critical workloads and risk areas, prioritize optimizations to reduce risks, and remediate by implementing improvements guided by this plan. Throughout, Microsoft Cloud Solution architects partner with you to ensure your apps become more resilient and efficient. This approach cuts through complexity and fosters continuous improvement. For practical examples and deeper dives, refer to the full session recording.